Hey everyone, today we're going to look at another proof. This is a grade 10 proof, the midpoint theorem, and this is how it goes. So the midpoint theorem is actually a theorem that's related to a theorem in grade 12, the proportionality theorem. So it's a special case of the proportionality theorem, and this is its statement. So it says, a line joining the midpoints of two sides of a triangle will be parallel to the third side and will be half the length of the third side. Okay, so say we have a triangle, any triangle. Let's name it P, Q, and R. And then let's have a point S on QP and a point T on PR such that SP is equal to SQ and PT is equal to TR. So if we join these midpoints S and T, this is the diagram given information, and this is what we are required to prove. We are required to prove that this length here is parallel to this one, and it is also half of QR. So the proof goes like this. Proof: we extend ST so that SU is equal to ST, then we join Q and U. Okay, then next what we'll do is in these two triangles, triangle PST and QSU, we're going to try and prove congruency. So the first statement says PS is equals to SQ. This was the given information. And then we also see that these two angles are equal. The angle here and the angle here are vertically opposite angles. So USQ is equal to PST. And this line that we just extended here, we made it to be equal to ST. So this is by construction, they are equal. Then as you can see now, we have three things that we've mentioned in each triangle, equaling the other three things in the other triangle. And these are two sides and an angle between them. So which means we can conclude and say PST is congruent to triangle QSU. The reason is side angle side, SAS. Okay, let's put that up there. Now, we then see that this means that PT, this side in the triangle, is equal to this side in the triangle. And PT was already equal to TR from the given information. Okay, then we also see that this angle here has to be equal to this angle here from congruency. But we see that these two angles are in a Z shape, which means they're alternate angles. This makes UQ parallel to PR or TR. Because the alternate angles are equal, parallel lines exist. Now, there's a theorem with parallelograms that says if you can prove that one pair of opposite sides of a quadrilateral is equal and parallel, then that quadrilateral is a parallelogram. So we have proved that UQ is equal to TR, and we've also proved that UQ is parallel to PR. So it means we can conclude and say UQTR maybe I should have said UQRT is a parallelogram. The reason is one pair of opposite sides are equal or is equal and parallel. Okay, let's take this up there. Then we see that since we have proved that this thing is a parallelogram, then we have proved one of the required to prove statements. We have proved that ST is parallel to QR because any parallelogram opposite sides are equal. So it makes this whole line parallel to this side, which means we can even say ST is parallel to QR. Then again, we see that UT must be equal to QR if this is a parallelogram. Now you see UT is from here all the way up to there, which means since these two pieces are equal, we can say that UT is actually 2 times ST. Then dividing both sides by 2, there we get ST equals to half QR, which proves the second part of our required to prove of our theorem. Thank you very much. This is the midpoint theorem. On GeoGebra, I have drawn the diagram for our theorem, and then I have color coded the 2 angles here. So this angle has TR is 125 and this one is TRQ, just so that you can confirm the property of these 2 lines being parallel. So since these 2 are coincident angles, they should add to 180, and this is clearly the case here. Then the lengths ST is this value here and QR is this value here. Then these on this side represents these 2 segments here, and it shows that they are always equal since T has to be the midpoint of PR. And this side, similarly, we have S being the midpoint of PQ, and this shows the value. Now again, this GeoGebra lets me play around with this diagram, and I can move the points around, and the values will move along with the points, with the points, yes. So this is just to show you that this diagram can be in any way, in any shape, and the theorem still holds. So as you can see, the angles here are changing as well as the distances. When I'm moving this point P, these distances don't change, they remain the same. What changes are the 2 sides and the segments that go with them. Then this values only change when I move Q or R. Then we can try and make this a right angle triangle here. So close. But almost got it. But you can see what I mean. We can move this point as well. The points I cannot move are these 2 because these have to do with where these 2 points are. So I can only move the corners of the bigger triangle. All right. So that's the theorem. Like and subscribe for more videos. Make suggestions on what other animations and demonstrations I can make in the comments below. I'll see you in the next one. Bye.